Hey, we're looking at Meyerline number 2 here. This is the second question. Anthropologists use linear model to relate femur length to height when discovering partial skeletons, and the model was created from a table below containing data on 8 different skeletons. And so here you see a series of femur lengths or leg bone lengths, and then the height of the overall skeleton. And as you would expect, as the lengths of the leg seems to get longer, so too does the overall height of the skeleton. The question then becomes, if an anthropologist finds a femur of 32 centimeters in length, how tall might the person have been? And so if you can imagine, what we're really kind of saying is, hey, if I have a 32 here, what would this correspond to in terms of height? And that point doesn't exist in the table, so we're going to use the Meyer method to predict or estimate a prediction of what that might be. So first step is to divide the data in half. We know there's 8, so cut that in half, top and bottom, 4 each. 1, 2, 3, 4. And then we're going to calculate an average x1 and y1 and an average x2 and y2 from the tops and the bottoms of these four calculations, if you look at it like this right here, that we have to do. So I'm going to get the average x's up here in this top left corner, add them all up, and that when you do, you'll get 168.5. Call that x1. And then divide it by 4 since there are 4 of them, and that's going to give me 42 for my x1. And then its corresponding y, when you add up those 4 and then divide by 4, you're going to get 628. Divided by 4, giving you 157 for your y2. Sorry, your y1. So x1, y1, 42, and 157. Then we're going to come down and get x2 and y2 over here. And when we do this, we add up those 4. For x2, we're going to get 200. Divided by 4 will give us 50. So the average here would be 50, or the mean would be 50. And then over here on the right, when we add up 172, 179, 174, and 183, we get 708, which we'll divide by 4 as well. And that will give us 177, and that's our y2. So we have an x1, y1 of 42, 157, and we have an x2, y2 of 50 and 177. x1, y1, x2, y2. I've just recopied them over here. So from here we know that we're going to have to go ahead and get the rule of y is equal to ax plus b in order to be able to make that prediction. And in order to do that, we're going to use these 2 points. So we'll get the A. The A will be equal to 177 minus 157 divided by 50 minus 42. So the A in this case is going to be equal to 20 over 8, which is equal to 2.5. So there's our A right there. And now we have to get the B, which we'll do with a little quick substitution. I'll use this x and this y right here. And so 157 is equal to A, 2.5 times x, which is 42, plus b. And now I just have to simplify this, and 157 is equal to 2.5 times 42 will give you 105. I'm going to subtract 105 from both sides, and I get 52 for B. So the last step now is to put the 2 pieces of information together, the A that I found and the B that I found, into one equation that will then allow us to make the prediction. So y is equal to 2.5x plus 52. There's our general rule. And we want to take that 32, which is an x value. It's always good to stop and check to make sure that you're putting it into the right variable, remembering that these are our x's and these are our y's. And so we're being given the femur length, which is the x. So it's going to go right there. And then we'll solve the y from there. So y will be equal to 2.5 times the x value that they gave us, right? That was the 32 sitting right there, plus 52. And so just 2.5 by 32 now is equal to 80 plus 52. Add them up and you get y is equal to 132 or 132 centimeters, which is exactly what would go into the table right there if it were to have such a data point. That's it.